All right. How does dividing radicals work? Almost exactly the same way as multiplying radicals. We're going to use, instead of the product rule, we're going to use the quotient rule, okay? The quotient rule says that if I am dividing, if I have a fraction under a radical sign, then that's the same thing as dividing two radicals. So this thing, square root of a over b, is the same thing as the square root of a over the square root of b. Okay, so a few steps with this. First, we're going to use the quotient rule to break apart a fraction if we see it. Sometimes it will already be split up like this, sometimes not. Then we're going to simplify our radicals. Then we're going to divide off anything that's the same on the top and bottom. And then we're going to simplify that result. So let's go ahead and start looking at number 1. First step, I want to use the quotient rule, break this apart into two radicals. Square root of 49 over the square root of 100. Second step, look for perfect square radicals and simplify them. Both of these are perfect square radicals. So when I simplify this, I have 7 over 10. Step 3, simplify, divide, and reduce the radicands if possible. Okay, there's nothing else to simplify here, and this fraction is already all the way reduced. Okay, so I can just leave it as so. There we go. Number 2, first step, split this up. Square root of 8 over square root of 32. If I had a perfect square in either of these, then I would go ahead and take the square root. I do not, so I'm going to simplify these radicals. Okay, so 8 splits apart into what factors? 32 splits apart into what? 16 and 2. You were ahead of us. Okay, now on the top, I take the square root of 4, I get 2 root 2. The bottom, I take the square root of 16, I get 4 root 2. Now it says simplify, reduce, and then divide off anything that's the same, right? So what's the same on the top and bottom? Root 2, root 2, and then I have 2 over 4. Simplifies to 1/2. Moving on to number 3. First up, split this apart. Root 3 over root 16. Do I have a perfect square radical here? Yeah. On the bottom, right? So I have root 3 over 4. Can I simplify root 3? No. And there's no coefficients that can simplify either. So this is as far as that one will go. Root 3 over 4. All right, let's move down to number 5. We're going to skip 4 for now. Number 5, this one is already split apart for us. Awesome. Let's go ahead and simplify these radicals if possible. Does root 10 simplify? It does not. It has factors of 5 and 2. Neither are perfect squares. Does root 45 simplify? What factors does it have? And I can square root the 9. So now I have root 10 over 3 root 5. Okay, should I leave my answer like this? What my rule with the quotient rule says that I can take a fraction that's under a radical and split it apart into 2. Well, I can probably go the reverse direction too, right? I have root 10 over root 5. I can divide those two things, okay? So I'm going to divide my radicals. What do I end up with on top? Root 2 over 3. Okay, so just like we can multiply under radicals, we can also divide under radicals. So I have root 2 over 3. I'm trying to see if that's in any of those steps. It just says, yeah. Divide the radicands if possible. So that's what we're saying there. We're dividing the radicands 10 and 5. Okay, number 6. This one's already split apart for us. Is there anything I can divide or anything I can square root? 36 goes to 6. Now 12, can I simplify that at all? Split apart into what? Now I can square root the 4 part, so I have 2 root 3 over 6. Okay, I only have one radical, so I can't simplify that any further, but can I simplify my coefficients? Yeah. 2 over 6 goes to what?
2 over 3. Wait, 3 root 3.
2 over 6. Divide the top and bottom by 2. It's 1/3. 1/3.
Oh, wait.
The 1 disappears. You don't need a 1 in front of your root 3. It's just root 3 over 3.
Wait, how long a period
Okay.
is it?
Let's go down to 12, and then we'll move on to the next page. Okay. This one looks a little funky, but let's do it anyway. First, can I simplify my radicals at all here? Can I simplify my radicals at all? On the top, root 84, what does that split into? Do we have a... Is it 16? How about 4? 4 and 21? Okay, 4 and 21. 21 does not have any perfect square factors. So that's as far as that would go on top. The bottom, I just have 15 root 7. Root 7 doesn't have any perfect square factors. So we square root the 4 part. That gives us 2. Multiply it with the 3 in front. We have 6 root 21 over 15 root 7. Now I need to simplify. So I'm going to simplify my coefficients. 6 over 15. What can I divide both 6 and 15 by? 3. So that turns into 2 over 5. Now it says divide my radicand. So I'm looking at 21 over 7. Gives me square root of what on top? Square root of 3. Okay, so you can divide under radicals. Any questions on this first page? Yeah.
So when we do a problem like this, and we can leave it like this because there's enough stuff to simplify.
Yeah, as long as both the radicands are simplified and then the coefficients are as well. Okay, flip over to the next page. There's a little blurb up here at the top. Okay, in order for your radical that's in a fraction form is to be fully simplified, you cannot have a radical in the denominator of your fraction. Okay, so all of the problems we did on the first page, there was no radical in the denominator of the fraction. That just happened by chance. Sometimes you will finish simplifying your problem and there will be one. So in order to get rid of a radical from the denominator, we have to do what we call rationalize the denominator, which is when we multiply the top and the bottom of your fraction times the radical from the denominator. So this little blank right here, it says to multiply or to rationalize a denominator, multiply both the numerator and denominator by the radical in the denominator. Then we will simplify a little further. Let's look at number 13. So in order to rationalize this denominator, that means that I want to have rational numbers in my denominator. Square roots are irrational numbers if they're not perfect squares. Okay, so I want to get rid of any irrational numbers, in this case, root 7 from my denominator. So I'm going to multiply the top and bottom of this fraction times the square root of 7. Do you guys remember yesterday, what did I say happens if you multiply a radical or square root times another square root that has the same thing underneath? Cancels out the radical sign, right? So on top, I have 4 root 7 now. What do I have on bottom? Just 7, because it's the square root of 49, which is just 7. So then I would check to see if I can simplify my coefficients. I cannot here. Now this fraction is fully simplified. Okay, so there's no radical on the bottom. We're good to go. Number 14. What do I need to multiply this by to rationalize the denominator? Square root of 2. Just the radical from the denominator. So on top, remember my product rule for radicals. I'm going to have the square root of what? 10. Square root of 10. And on the bottom, what do I have now? 2. Just 2. Yes, you can officially rationalize numerators as well. However, that's not a common practice for math because simplest form typically denotes that the denominator is rationalized, not the numerator. But you can do this on the top as well.
If you have both of them, you should do the bottom.
You should do the bottom. Okay, number 15. I'm going to break this apart first. This is the same thing as square root of 81 over the square root of 2. You don't have to do this, but okay. Now, I don't know. This one I could go ahead and take the square root on top. Let's go ahead and do that so we have it. 9 over root 2. Now, in order to rationalize my denominator, what do I need to multiply by here? Root 2. I'm going a little out of order, but that's just because I saw the 81 on top, and I didn't want to multiply 81 times 2. Okay, nothing to simplify here again. My gosh, I keep getting these things on my page. We're going to move down to the bottom of our page, number 23. Okay, 23. It does not just have a single radical on the bottom. It has a coefficient as well. But that does not change how I'm going to do this process. I'm still just going to multiply by the radical in the denominator. So on the top and the bottom of this fraction, what do I need to multiply by? Square root of 8. If you multiply by 2, this 2 root 8, it will still officially rationalize your denominator, but there will be more steps you will need to do to simplify. Okay, so root 8 on top and on bottom. So on top, I'm left with square root of 24. On the bottom now, I have 2 times 8, 16. So let's simplify. 24, what can I split that apart into?
6 and 4.
Okay, on the bottom I have 16. Square root of 4 on top, so I have 2 root 6 over 16. Now I'm going to simplify my coefficients. What can I divide the top and bottom by? 2. So I have square root of 6 over 8. Okay, I want you guys to do number 24. 24, and I'll have the answer on the board, and then we'll move on. Times.
No. Yeah. What you say? 16.
Any questions on this one?
Can we go over it?
Yeah.
Oh, wait. You did.
Okay, so you multiply the top and bottom times the radical from the denominator. That gives us 4 root 60 over 12. Then 60 breaks apart into 4 and 15. Square root the 4, you get 2. Multiply that in front, you get 8 root 15 over 12.
Wait, how did you get to the 8 and 15 over 12?
I square rooted the 4, I got 2. I put that 2 in the front and multiplied that with a 4.
Okay.
So that gives me 8. And then I simplify 8 over 12 by dividing top and bottom by 4. And I have 2 over 3.
Okay, that
Okay? All right. On the back side,
there's more. Oh my god.
we do have a little bit more. All right. Back side. What happens when I divide binomials by radicals? So multiple terms by radicals. We're going to follow exactly the same process, but we'll see that when we multiply the top and bottom by the denominator's radical, we're going to have to distribute on top. Okay, so number 1, what do I need to multiply by to rationalize this denominator? Square root of 2, square root of 2. Okay, now on the top, I have this binomial times root 2, which means I actually have to distribute that root 2 to both of these, which would give me 2 root 2 plus root 10 over 2. Now, in order to simplify in my final step, I need to have coefficients that are all divisible by the thing on the bottom. I only have coefficients of 2 and 1 on top, and a coefficient of, well, just a number of 2 on the bottom. 2 and 1 are not both divisible by 2, so I can't go any further here, okay? Root 10 does not simplify either. So that's my answer. Let's look at 2. What do I need to multiply by here? Square root of 3. Okay, so yet again, I have to distribute to both of these terms. I have 4 root 3 minus 3 over 3. can I simplify this? In order to simplify this, and this would need to have a common divisor. None of those do. Okay, so that's as far as that one will go.
Would they all be divided by 1?
Officially, yes, but it wouldn't change the answer. Yep. Okay, number 3. What can I multiply this by? To rationalize. Root 2 and root 2. Okay, so on top, again, distribute. Whoop. So I have, 4 times root 2 is just 4 root 2. And then root 2 times negative 6 root 2 is minus 6 times 2 over 2. Now simplify on top. I have 4 root 2 minus 12 over 2. Okay, I have one more step here. Why? Because 4, 12, and 2 are all divisible by what? 2. So I have 2 root 2 minus 6 is my final answer. 2 root 2 minus 6. Notice I didn't change the radical when I divided by 2. That's because you can only divide radicals by other radicals. So that radical is going to stay the same. I'm only looking at the coefficients on the top. Yes?
Negative 6 times 2.
So I took this and this. When I multiply those, the negative 6 is the coefficient, multiplied with 1 officially. So that gives me negative 6.
Takes this distributed 2.
Yep, and then the root 2 and the root 2 multiply to 2. Okay, I want to do one more. Can we do number 6? Number 6, because what do I need to multiply the top and bottom by here?
8. Square root of 8.
Just the square root of 8. I don't need to worry about the 4. On the top, distribute. So I have 5 root 8 minus root 40 over 4 times 8. Notice how the coefficient stayed there. It's still 4, but now I have root 8 times root 8 gives me 8.
Wait, so you multiply the bottom?
What was that?
You multiply the bottom, you don't add.
Yes, always multiply. Okay, now I have 5 root 8 minus root 40. 8 has factors of what, though? Okay, so I have 5 root 4 times 2 minus root 4 times 10 over 32. Square root the 4's in both of those radicals. So the first one, square root of 4 is 2. Multiply that in front, you get 10 root 2. Second one, I just take out of 2. There's nothing to multiply it with. Root 10 over 32. My last step here, what can I divide all of this by? We're looking at the 10, the 2, and the 32. All the coefficients, all divide by 2. So I have 5 root 2 minus root 10 over 16. Sorry. Oh, wait. Never mind.